Hello, all you kittens and cats. This is GoFormative Help number 19. And this is about decimals. If you've never added decimals before, it's important that you remember to line up those decimals. 0.24 needs to be lined up with 0.36, and then you're just adding them together. That's if you want to do it by hand. A lot of kids are just going to do this in their calculator, and that's also fine. But if you want to know how to do it by hand, line up the decimals when you add or subtract. And 6 plus 4 is 10, carry the 1. 1, 2, 3 makes 6, so it is 0.60. And that is what you're looking for if you're doing it by hand. And that is a bunch of them like that. Line up the decimals, line up the decimals, line up the decimals. Line them up, line them up, line them up, line them up. Let's do something like this together. So I would do 3.4. And then do you see how the point here, I need to make sure the points line up. So the 5, 4 goes there, the 8 and the 4 and the 6. Okay? These just become like empty spaces of nothing, zeros. So this is 6 and 4, and this is 12. Carry the 1. 1 plus 3 is 4, plus 4 is 8. The decimal comes down, and 5. So this is your answer, looking for that. And that's how you do adding decimals. You can just line them up. Line them up, line them up, line them up. Let's just make sure nothing else pops up here. Here we go, something else. So this is a fraction addition problem. And it wants it in, the answer is in percent. So how do you do this? Well, what's 1/5 plus 2/5? Remember, it's 3 because we're adding the tops. These add. The bottoms don't add together. Some kids put this. This is wrong because 1/5 of something plus 2/5 of something is not 3/10 of something. It's 3/5 of something. Now 3/5 is 60%, whereas 3/10 is 30%. So you want to keep that in mind when you're talking about percentages. Another way to look at this is, if we rewind it, okay, look at it this way. This is 20% plus 40%. So that's another way to look at it. If you divide these in your calculator and be like, okay, that's 0.2 and that's 0.4. So if we add them, it's 0.6 or 60%. That's another way to do it. That right there is for the kids who tend to add the bottoms together. The denominators, the bottom numbers, we don't add these. If they're the same, just add the tops and keep the bottom the same. That is how we add fractions. What if they're different? Good question. I know you were thinking it. Well, we got to make them the same, right? So the question becomes, how do I make 4 and 10 the same? Well, you have to kind of think back to like, what do 4, 8, what does 4 and 10 have in common? And if I count my 10s, do you see any number that's the same in both those? I do. Okay, so that one and that one, which means 4 times what is 20 and 10 times what is 20. And whatever I do to the one side, the bottom, I have to do to the top. So all I'm doing is making this so that I can actually add them. So now that's 20 and that's 20, but this is now 4 and that's 15. So I'm rewriting these, and I'll do that in a different color next to it so you can see it. This is now 15 over 20, and this is now 4 over 20. And if you look at this fraction, 15/20 plus 4/20 is 19/20, because we're not adding the bottom numbers. Okay, super important. Not adding the bottom numbers. The tops add when the bottoms are the same. So that is your little fraction kind of addition help. what do we do if we're multiplying fractions? Now, this is why kids add the bottoms on those other ones, because when it gets to timesing, or timesing, there's that word again. When we get to multiplying, we want to multiply across the top and multiply across the bottom. So it is 1 times 2 is 2, and it is 3 times 5 is 15. So we are, when you're multiplying, yes, multiply the top, multiply the bottom. 2 15ths. Same thing there, multiply the top, multiply the bottom. Here, we're subtracting. Are the bottoms the same? Yes, then it's just 8 minus 2. 6/5. Are the bottoms the same? No. So we have to make them the same. Again, this is, I mean, you're in 7th grade, going to 8th grade, you're going to do 9th grade math. I would like to think that you know how to do that, but we just need practice at it. So 5/3 minus 4/5. A lot of kids just throw this in their calculator, or maybe they're at the point where they're like, don't know how to throw it in your calculator. But let's just work on how to get the bottom numbers the same. So count your 3s until you feel like, you have a number that matches when you count your 5s. 3, 6, 9, 12, 15, 5, 10, 15. Do you see a number that matches? So we can make both those bottom numbers into 15s by multiplying 3 times 5 and 5 times 3. But because I multiplied this by 5, I have to multiply that by 5, and same thing here. Whatever I do the bottom, I have to do the top. So now I can rewrite those fractions. This now becomes 25 over 15 and 12 over 15. And so it kind of looks messy, but I'll rewrite it. 25 15ths minus 12 15ths. 25 15ths minus 12 15ths. But because the bottoms are the same, all I'm doing is subtracting the tops. So what is 25 take away 12? And again, you can just use your calculator. 13 15ths, and that's what you're looking for. And that's kind of big picture on the fractions. Can I do that by hand? And again, if you have to use your calculator, who cares? I mean, at this point, it doesn't matter. Just use it, if you know how to use it. Another way kids can do this in their calculator, you can take 5 divided by 3, get a decimal for it, and subtract it from 4 divided by 5, because that decimal will be the same decimal as whatever 13 divided by 15 is. So that's something you can do. Dividing fractions, dun dun dun. There's a dividing trick when you're dividing fractions. It's called keep, change, flip. You've all heard it before. You've heard me say, you've heard it before me. It's just a matter of remembering, okay, when I divide fractions, I'm keep, change, flip. So what that means is the first fraction you're keeping the same. So 8/5 is going to stay the same. The change part is your sign. You're changing it from a division to a multiplication. The flip is you are flipping 2/5 to 5 over 2. You're just flipping it, inverse operation. Okay, so now we can do multiplying straight across. 8 times 5 is 40, and 5 times 2 is 10. So 40 over 10. And then we can reduce that. That's a big fraction. So 40 divided by 10 is 4, which is why that's lit up as 4. Okay. And there's another divide one. I want you to try that on your own. If you need to see the video again, you can practice keep, change, flip. That's okay. Let's move on to this one. This is just adding like terms. They all have x on them, right? So think of it like 8 plus 5 plus 2 minus 6 minus 7. Just think of it like a addition and subtraction problem. 8 plus 5 is 13, plus 2 is 15, minus 6 is 9, minus 7 is 2. So think of it like that, where the answer is going to be 2, but you need the x on it. Okay, so don't just put 2. let's see. Similar there, except for this one's harder because I included y. Remember, x's and y's do not add together. So 20x will only add to this one, 5x, and it will only take away from 16x, and this one, negative 6x. But the y's will go together. So this is 3y, take away 5y. This problem is actually one of the hardest ones on here today because of the mixed letters. So what I do is I just keep them together. So write down, make a list, 20x goes with 5x, and then you're taking away 16x, and you're taking away, so just make a list of what you have. And then do the same thing with y's. I have a positive 3y and a minus 3y. So this is going to be negative 2y. And then all this is 25. This is negative 22. So 25 minus 22 is 3x. So you're looking for an answer that has both of these in it. And that's why it is lit up as is. Okay. Here you have a solve for x problem. We used to be, maybe we still are, brush off the solve for x tools. One of the most, I guess one of my favorite parts of the school year for me is how proud I am of my students. It doesn't matter if you have an A, B, C, D, F. It doesn't matter what your grade is. 100% of my students know how to solve for x, which is so cool because it's a 9th grade skill, and I'm really proud of that. And so if you remember and you're sitting there right now, hopefully we know how to solve that for x. We want to distribute first on the right side. So that 2 is going to go into 3x minus 3. It looks something like this. A little remember there. 2 times 3x is 6x. And 2 times negative 3 is negative 6. And I'm sitting here with something like this. And some people will remember, since they're both 6x, they cancel, they're done. And what am I left with? Negative 3 equals negative 6. Is that a true statement? Does negative 3 equal negative 6? No. And that's why no solution is lit up there. What if they did equal the same? What if it was negative 3 equals negative 3? Then it wouldn't be no solution. It'd be what? Infinity? You betcha. I won't solve that one for you. It's much like the same as the one we did just now. Just don't forget to distribute on both sides. Explain the difference between the answers in the previous two problems, 21 and 22. Explain your reasoning. Well, one of them is no solution and one is infinity. So when you go to explain this, you're going to say something like 21 didn't end with a real solution. Negative 6 doesn't equal negative 6. That's a false solution. So therefore, no answer can be for x. So that's why x is no solution. And 22, since I'm guessing, because that's infinity there, that you get some number equals the same number over there. You get like negative 6 equals negative 6. So that's a true statement. So therefore, any answer will work. More solve for x. Show your work on that. Let's talk about graphing for a second. This says explain in your own words how to graph the following. So you're going to write out a sentence and you're going to explain that. So let's just talk about graphing for a second. Let's just even change this paper. And then let's just make a graph real quick. Because we can. Unless we're sloppy. Okay. X-axis, Y-axis. How do you do that problem right there? Well, where do we start? We start on the Y-axis at positive 2. Why? Because it says positive 2 right there. So we're going to always start at the end. If there was nothing there, it was covered up, then we'd start at the origin. But because there's a 2, we're starting here. Now this is a negative 1/2, which means we're not going up 1 over 2. We're going to go down 1 over 2. So down 1 over 2, down 1 over 2. How many points do I need on a line for a line to be a line? I just need 2 points. I have 3, and that's allowed, but you just need 2. So hopefully, I know you're not graphing this one. It says explain in your own words, but in your own words, you would say start at 2 on the y-axis, then go down 1 over 2. So in this one, how would you say it? Start at -1 on the y-axis, right? And then I'm going to go up 1 over 3. Up 1 over 3. So you can see my line there. And that's what that graph should look like. This one a lot of kids got wrong. Just, these GoFormatives are so long that by the time they get to number 19, this is the number 19 GoFormative, and this is number 27 on that. you just give up. And so I looked at all these answers, and there's a lot of them are just wrong. So don't give up. Keep going. This is a greater than or equal to problem, and it's also a solve for x problem, and then you're going to graph this. So I will do this one with you. 1/2, and by with you, I mean I'll do it for you. You're welcome. X plus 3. So you really, what's half of 4 and what's half of 10? Right? Half of 4 is 2, and half of 10 is 5. And now we're just, you can ignore this inequality for a second, just till the end. We can ignore that. So go ahead and ignore that. But solve for x. So we can do that together. We know how to do that. So subtract x on both sides. This is now x plus 5 is less than 3. Subtract 5 on both sides. This is now x is less than -2. And that's okay. So when I go to do my graph on your line, beautiful line, just indicate where 0 is. It's fine. It could be like that. Maybe this is 1, 2. It doesn't matter. Call it whatever you want. -1, -2, So let's just say that's what you did on your graph. Go to your -2, do an open circle. Why is it open? It's open because that is a less than symbol. There's no equal to line under it. So it's open. And then we're shading which direction? We're going to shade to the left. Why? Because it's also pointed. This arrow tells us which way to shade, which is nice. Okay, that's probably the hardest problem on there so far. I think that's it. I'm not sure what the type of text is. I'll delete that. All right, we're good. Smashed it, crushed it. Make sure you get that one filled out all the way to number 27. All right, thanks.